I've been getting asked if I know anything about these 60 class cards. When are those coming? What do we know about them? Well, the rumor mill is heating up now that the 70 class cards have launched. The latest is a claimed release date. However, again, this is not official from Nvidia. This is at WXNod on Twitter. Now, this source has leaked things accurately in the past, but we would still put this on a sliding scale between random person we know nothing about and official from Nvidia. You know, it's somewhere between, right? Anyway, saying 5060 Ti will be released on April 16th at 9 p.m. I mean, the timing I wouldn't worry too much about because that depends on your time zone anyway. This would be consistent with Asian embargo lift times, though. April 16th being a Wednesday is a bit odd for Nvidia reveals. Usually embargo lifts are Tuesdays or Thursdays, but the 5070 was a Wednesday, so it's certainly possible. And the claim of it coming in an 8GB and a 16GB model is consistent with other leaks regarding the 5060 Ti that we have. More on the specs leaks for the 5060 Ti in a minute, because we also have this regarding a 9060 XT 8GB and a 9060 XT 16GB. Now, this one is coming backed up with actual filings from the National Radio Research Agency in South Korea, and this filing coming from ASUS and mentioning like prime, dual, tough models, etc. So this seems pretty legit as far as this goes. Now, this doesn't tell us much on the specs other than the memory configurations of 8 and 16, but it does mean that it does seem like AMD is working on their 5060 Ti competitor. Again, the fact that this is branded as an XT version for the 9060 is indicating that this would be a Ti competitor from Nvidia, the way AMD seems to be placing their naming scheme in the current generation. Now, let's talk a little bit about the specs and these 8 and 16GB variants and all of that. Let's start with the 5060 Ti. This is videocards.com's chart, and they have claimed their specs for the 5060 Ti to be based on their own sources. Videocards.com has a good accuracy track record when they're citing their own sources. Now, do keep in mind, and this is I think hard for a lot of people to track, that there's a big distinction between a videocards.com article that is citing some other leak versus a videocards.com article which is citing their own sources. I would grade that when they just cite random leaks, then it's just, well, what is the quality of that random leak they're talking about? But when they cite their own sources, their track record has been pretty good. So anyway, with all of that being said, again, none of this is official. But there have been other leakers stating similar specs and things like that, so this is all sounding to be pretty likely, even if it's not 100% confirmed. Now, the 5060 Ti stacked up against the 4060 Ti, we can see that there's not a massive core count increase going from 4,352 to 4,608. Not a giant leap. However, there is a giant leap in memory bandwidth, going from 288 up to 448, even though they're both on a 128-bit bus. The reason that that could happen is due to the move from GDDR6 memory to GDDR7 memory, increasing the memory clock to 28 gigabits per second versus 18. So it's looking like, especially because now the CUDA core count between architectural generations is not always an indicator of a performance improvement, because you could get more performance per core on a different architecture. However, the way I've interpreted the 50 series reviews so far and launches is that it does not seem like we've seen a large gaming improvement per core. It's been fairly similar, and then maybe things like increased memory bandwidth or cache and things like that having, and power limits having more to do with the increase in performance that we're seeing, which isn't massive, generationally here. So that's what we see here. Now, again, coming in an 8GB and a 16GB model is the rumor, and let me give some thoughts on that. First of all, let me address the common question I see in the comments all the time. Why 8 and 16? Why not 12 or 12 and 16? Well, that comes down to the way a memory bus works. If you have a 128-bit bus, you can only fit in so many memory modules per bit, basically. So that limits you to an exact number of memory modules. Now, if you can fit 4 memory modules, and then you could fit in 2 gigabyte chips on each module, that gets you 8. Then you could go into a clamshell design, fitting some on the front and some on the back. That's what happened with the 4060 Ti 8 and 16 gigabyte version, which can then double what you had from there. So basically, you could go with 8 or 16 in a clamshell design, not with 12 unless your memory modules supported 3 gigabytes rather than 2. Now, GDR7 memory does seem to have some variance with 3 gigabyte modules, but the timing on are they available and is Nvidia pushing to use those and things like that, so far with the 50 series has been they have not really been using those trying to get into those 3 gigabyte modules on this initial launch. Whether we'll see that later in like a super version next year, maybe that's what Nvidia is planning with their super variant. But the point is, it looks like while the GDR7 memory will increase the memory bandwidth, it's not going to allow us to go into like a 12 gigabyte model, which I think would be more appropriate. So maybe it would have been nice if Nvidia had designed a chip with a different memory bus, but they didn't. So if it's 128, I mean, according to the rumors, then those are your options. That also explains, again, why AMD leak of the 9060 XT coming in 8 and 16 rather than something like 12. So if you're designing a 128-bit bus, those are your options. I think that's a bit disappointing, but there it is. Now, my general thoughts here is that an 8 gigabyte card, if the pricing, because last gen, the 4060 Ti came in at $400, and then the 16 gigabyte version came in much later at $500, although often was then discounted about $450. Now, so far, we don't have pricing ideas on these, but NVIDIA's MSRP, which whether those are realistic or not is another matter, but so far NVIDIA's MSRP strategy for the 50 series, well, we saw the 4070 essentially coming in, the 5070 essentially coming in $50 less than the MSRP of the 4070 at 600 knocked down to 550. Of course, real world pricing hasn't really lined up too well with that. And we've seen a similar strategy with the 5070 Ti, where the 4070 Ti was $800, the 5070 Ti was $750. Again, if we're talking MSRPs and pretend those matter, at least for now, hopefully in the future, supply will improve. Anyway, the point is, so what would we predict for MSRPs on this? I mean, could we see the 8 gigabyte model come in at 400 minus 50, so 350, and then the 16 gigabyte model come in at 500 minus 50 at 450? Or it'd be, I think, more appropriate at 399, depending on what its performance is. If you mark down 50 from what the 16 gigabyte generally sold for with the 4060 Ti. I mean, we'll have to see what NVIDIA does with this. Honestly, my thoughts on an 8 gigabyte card is even at 350, that's a lot of money to spend on an 8 gigabyte card when we see a lot of games, even at 1080p, at their max settings at least, going well beyond 8 gigabytes. And dealing with running out of VRAM is a really frustrating thing to deal with because it's not always obvious what is causing your performance issues, or even obvious that you're going over. Sometimes you just see bad looking textures and you don't understand why. So I really don't like that. Like, you could consider it as like maybe an esports card where, okay, I don't play graphically demanding games and I turn down to low settings, I'm playing esports, whatever. So I'm not saying that there aren't people who are going to be fine on an 8 gigabyte card, but that just feels like a lot of money for a card with a lot of performance potentially. So it could perform well enough to run games at settings that go well beyond 8 gigabytes, but then you only give it 8 gigabytes. That seems kind of bad. So I'm hoping the 16 gigabyte model comes in at something like a reasonable price. Is that going to happen? Well, so far MSRPs haven't really mattered anyway, given the real world market pricing, so we'll have to see what comes of that. Now, we seem to know less about the 9060 XT to compete with the 5060 Ti, other than it seems to be an 8 or 16 gigabyte model. Again, similar thoughts on the VRAM capacity there as I just gave for the 5060 Ti. 8 doesn't seem great for a card at that performance tier, at least the performance tier we would be expecting here. So unless pricing is super low, then like I said, might fit some users' use cases, but I don't think would be a good general buy at a very high price. 16 hopefully comes in at a reasonable price. We'll have to see. The fact that you're using GDR6 here instead of GDR7 is potentially going to help rein in the cost on that. Maybe we'll have to see. Anyway, we don't know a whole heck of a lot about that at this point. Now, speaking of pricing being bad and it seeming to have something to do with not amazing supply from the supply side, and then if you have more demand than you have supply, what you get is scalping. So this was a really interesting post I saw on Reddit here saying, I tracked the prices of sold Nvidia GeForce 5090 FE on eBay. The data is interesting. I do think this is interesting. So basically, one thing to note here is this is not tracking all 5090 models. This is tracking the 5090 Founders Edition specifically as eBay pricing with a blue line of the max price, a red line of the min price, and a yellow line of the average price. So that's what we're looking at here. And what you can see is that it does have a downward trend over time, although after this initial craziness, it has kind of flatlined a bit, but this is still a downward trend, especially on the average pricing. Notice it was well above $4,000 and is currently averaging below $4,000. So that is hundreds of dollars down, but still taking a while for it to trend that way. Now, there is some other information in this data set. So for example, the standard deviation on the pricing is over $1,000, which does, I would agree, indicate significant volatility. Standard deviation, if you're not a statistics person, is essentially the average distance of your data points from the mean. So if the mean pricing is 4,635-ish, saying like the average distance of sales prices from the mean is over $1,000. So that indicates a lot of volatility. Standard deviation, the math teacher in me wants to clarify, it's not actually, everybody says the average distance from the mean. It's really the, you square the values and then you square root again at the end after doing the average. So it's technically not quite the average, but anyway, by squaring it, you increase the influence of outlying values. But I'm gonna just stop now because this is not a math lesson. Okay, reining myself in. Anyway, the point is that does indicate a lot of spread from the mean in the data set, if that's over $1,000 difference. Maximum price sold at was $10,000. Wow, look at that. Anyway, if you look at just March rather than the whole data set, notice that the mean for just March is hundreds of dollars less than the full data set since launch, and the median price is a couple hundred down as well. And also the standard deviation is much lower at about 146. So you can see that this is, there was a lot of craziness right here at the beginning, and then it drops down. Anyway, so this is at least showing that the price is trending down on at least this one model in the used market. Now, how do we continue to get prices to trend down? Well, if supply increases at retail, and if the people who are willing to pay those crazy prices already get their card, then things will hopefully start to trend down more for all of the cards. So part of this needs to be a supply solution, and then part of it needs to be a people willing to pay crazy stuff on the demand level decreases as well, and then things will get better over time. Hopefully, that's what we'll want to see. Now, there have been some other interesting updates from Nvidia I'd like to report on here. There is a new app version of 11.0.3, and this allows something really cool with the DLSS override stuff. So you can now adjust the input render resolution for DLSS super resolution, enabling precise tuning of the new transformer model to optimize performance or enhance image quality. Available for supported titles under graphics driver settings, DLSS override super resolution. So the idea here is that, DLSS usually has certain quality presets. There's native resolution using DLAA. There's performance mode, which is 50% per axis resolution scaling. There's quality mode, which is 2/3 per axis. The point is that there wasn't a lot of granular sliding in between those preset settings. This is allowing you to more finely tune the exact percentage of the resolution scaling that you want per game, which is kind of nice if you want to play with that. Anyway, there's a few other features here, including adding some stuff that was in the control panel into the Nvidia app. Remember, it looks like Nvidia's long-term plan is to replace their control panel with their Nvidia app, where they're kind of merging how the control panel and GeForce Experience used to do different things. It seems like they're trying to get everything into one app called the Nvidia app. This is moving display scaling settings, letting you choose different scaling modes, including integer scaling, and decide whether the GPU or the monitor handles the scaling process. This was all stuff that was done on the Nvidia app. This is now done on the Nvidia Control Panel. This is now available in the Nvidia app under System and Display. The Nvidia Control Panel is still there and still has these features, but they're trying to bring these features into the app. Also, display color settings. They've added some optimal settings, well, what they call optimal settings for more games, and fixed a few bugs, it looks like. So there's that. Now, a more widespread advancement we've seen announced at GDC is regarding DirectX Raytracing 1.2, PIX, and neural rendering. So this was discussed at GDC recently. Now, the move to DirectX Raytracing 1.2 seems to be to bring some advancements that were NVIDIA-specific APIs more into the actual DirectX umbrella. Specifically, talking about opacity micromaps and shader execution reordering. Now, I do think that the GPUs to support this still need to have some level of hardware and driver support for these features, but them getting added into DirectX rather than just being an NVIDIA-specific API, I think is an improvement and a step towards ray tracing getting better for all cards and vendors. Now, as far as what these do, so opacity micromaps significantly optimize alpha-tested geometry, delivering up to 2.3 times performance improvement in path-traced games. By efficiently managing opacity data, OMM reduces shader invocations and greatly enhances rendering efficiency without compromising visual quality. Now, do not take this at up to 2.3x as indicating that all ray tracing or all path tracing games are just going to be 2.3 times faster on any GPU that supports this. It's not what this is saying, but if there's a lot of alpha-tested geometry and a lot of opacity happening there in a particular scene that is heavily reliant on that path tracing, then this can produce a lot of improvements in the performance there. Same kind of idea with shader execution reordering is that in specific situations, this can be much, much faster than if you don't have support for this. So this is saying it offers a major leap forward in rendering performance, up to 2 times faster in some scenarios, by intelligently grouping shader execution to enhance GPU efficiency, reduce divergence, and boost frame rates. Making ray trace titles smoother and more immersive than ever, this feature paves the way for more path trace games in the future. Again, this is stuff that NVIDIA has been relying on in a lot of their path tracing implementations, where they added support for this 2 years ago with their RTX 4000 series for OMM and shader execution reordering. So the idea of this getting into DirectX, I think, could mean that realistically, while AMD moved forward a lot in their ray tracing performance with their 9000 series launch, in the path tracing implementations we've seen, they've still generally fallen very far behind. Now, there could be a lot of reasons for this, but one reason I've been speculating is that those games have OMM support and shader execution reordering support on NVIDIA hardware because NVIDIA launched their own version of this before it was a DirectX feature. If this becomes more just widely supported by multiple brands, I wonder if we could see an improvement in path tracing performance on non-NVIDIA hardware. But again, you do need hardware support, driver support for all of this. Also, I think one of the big advantages NVIDIA still has is with their ray reconstruction, which is like a neural denoiser and super sampling technique that they use for path tracing. And with that, actually brings this other update to DirectX. So DirectX bringing in cooperative vectors and neural rendering. So the idea here is that this will make it easier to implement these types of neural rendering techniques just as part of DirectX rather than needing to be, I think, so vendor specific. And this is coming soon in Shader Model 6.9. The idea is it introduces powerful new hardware acceleration for vector and matrix operations, enabling developers to efficiently integrate neural rendering techniques directly into real-time graphics pipelines. And again, they had support from AMD, Nvidia, and Intel talking about these types of things, talking about neural block texture compression, which seems to be able to deliver higher fidelity textures, but with a smaller memory footprint than if you were doing it the traditional way. And then also talking about real-time path tracing being enhanced by neural supersampling and denoising. AMD has showed off a version of their neural denoising and supersampling. It didn't look very amazing in their demo, to be honest, but I'm glad they're working on that, because that's a place where I think NVIDIA still has a massive head start, is the new transformer model of ray reconstruction looks excellent. It made a massive visual improvement in games like Cyberpunk, where I've tested it out, especially even compared to the previous version of ray reconstruction. So this is a place where I think competitors really need to step it up, but the fact that support for this coming more into DirectX rather than needing to be so vendor specific is my understanding of this, I think is only a good thing. Now, overall, these sound like good updates, but again, I'm not a game developer, so perhaps, maybe I don't fully understand, how all of this will play out. But I think in general, getting stuff into DirectX rather than just being a vendor-specific API is a good thing for the development of all of these technologies. Last thing I'll leave us with here is that we did get a systems requirement list for Silent Hill F, along with a trailer, and I didn't end up doing a separate video on this, for one thing because Silent Hill F seems to only just have a minimum and recommended spec, and also the details on what exactly that means, a little bit low, so I'll just throw it in here. So the minimum spec is a GTX 1070 Ti or RX 5700, but this is just for 720p 30 FPS, and they're saying that that's on minimum requirements, should be able to play on performance quality setting. Now, they don't mention whether the performance setting is using DLSS or FSR or anything like that. Now, if we look at the recommended settings, it may indicate that the performance setting is not relying on upscaling, because they say that for the recommended settings, playing on recommended requirements should enable to play on performance settings in 60 FPS or quality settings in 30 FPS at full HD, meaning 1080p. However, they then say, or at 4K using DLSS or similar technology, indicating that here they actually are mentioning upscaling separately from the performance or quality settings, indicating that the initial statement may not be requiring upscaling in order to hit that. Now, so at the performance settings, which are potentially native resolution 1080p 60 FPS, or at the quality graphics settings, I would imagine this kind of lines up more with how the consoles do, kind of like a 60 FPS mode versus a 30 FPS mode. I'd imagine that's kind of the graphics presets that we're talking about. Those are at 1080p output. Then they're saying that you would need an RTX 2080 or AMD Radeon 6800 XT. Now, generally, a 6800 XT would be more in line with a 3080 rather than a 2080. And that is a massively different performance level unless we're talking ray tracing. So that makes me wonder if Silent Hill is relying on ray tracing here for this. We'll have to see. Anyway, like I said, they are talking about then using potentially DLSS to boost to higher resolutions and all that. So that's what I've got for you on Silent Hill F. I hope you guys found today's video useful and or interesting, and I hope all of you have an excellent day.